We are doing 5.5 curve sketching, and again, as I say pretty much every day, you will notice that it's basically putting together a lot of the stuff that we've learned so far and a lot of the old stuff from last year and previous years. So if you take a look at this, if it says the goal is to accurately sketch the behavior of a function, we've done all of that in Pre-Calc 12 and 11 and other courses where we did like a table of values or we looked at, specific points. So now we're looking at it again from a different perspective using our calculus skills, but there is still some of that old stuff. For example, like we'd want to look at the domain, that would be something we're interested in. X and Y intercepts, that's not really calculus, that's old stuff. Asymptotes, we could do that either way, but since we're doing calculus, let's use that method. And then all of this stuff we know is involving our derivatives and all the skills that we've been looking at. So I just thought it would be helpful if I put that out there all summarized so that it's clear for as we're going through each example, but that's basically what we'll do here. So if we are asked to graph this function, f of x equals 5x squared minus x cubed, you've learned methods in Pre-Calc 12 that could allow you to graph this out. So the difference is now that we're going to apply all of our new stuff in order to do this. But let's go through each of those points that I just listed so you can start to see what the key aspects are and what we would be wanting to look at or to use. So, since f of x is what function is f of x? Do we all recognize that? What kind of function is it? Like, how we learned like rational functions, radical functions, all of that stuff? Having some problems here. There we go. What is it? Oh boy. Good thing we're just doing the one lesson today. Polynomials? Oh no, you're still shaking your head and saying no? Yeah, binomial is just a type of polynomial, right? So polynomial is the general name, and then two terms would be binomial. Yeah.
Cubic.
Sorry?
Cubic function.
Cubic. Good. That's even more specific. Is this all starting to come back to us? Okay. Good thing we're doing the review today. I'm glad that we're doing this. Okay. So, it's not a big deal. You didn't need to know that. I just figure throw in review so that it starts to come back a bit, right? Okay, so do you remember the properties of a cubic or of a polynomial? Like, what would my domain be? What would I know about my x values for a graph like this? Do you remember the general shape of a cubic? Yeah, it's either like that or like that, depending on the lead coefficient, remember? So, if you have that type of shape, what would the x values be that were covered? Yeah, so we could say x is an element of, remember that symbol, all real numbers. And if you, I'm not picky with giving the specific formal, but just tell me that x is all real numbers, but that would be the proper notation or way to write it. And how about our range, which is our y values? Same thing, right? Y is also all real numbers because we would assume that those arrows at the end indicate that it's going to keep going left to right and also top to bottom. So there's, I guess, a little bit of review with that. So I'm going to put that as step number 1. Step number 2, let's look at the intercepts. So intercepts, we want when y equals 0, that's the first thing I want, and then we want x equals 0 because by definition we know that that's what intercepts mean. So it's just a matter of us plugging it into here, right? So I take my equation here, and y would be the same thing as that, so I'm going to plug in 0 equals 5x squared minus x cubed. You get to see that each year you were learning little individual skills like factoring and all of that stuff, and you now get to see it all put together and you see the reason you learned it. Because in order to solve this, we need to factor, right? So I look at both terms and see they both have an x squared. I can pull that out and I'd be left with 5 minus x. If the whole thing is set equal to 0, do you see that each of these, you know what's off today? My color coding. It's just not, there we go. Oh, okay, forget that. It's not happening, everybody. Do you see that this would, if this was 0, if x was 0, then the whole thing would be 0, right? And here, if x was equal to 5, then the whole thing would be 0. So, does that make sense to everybody? So my x-intercepts would be at the point 0, 0, and the point 5, 0, because we know that we use this 0 up here for our y value in order to get it. So I'm going to put that in a box because that's what we would use in order to get this. For x equals 0, I'm just going to do f of 0 into my equation. So from here, I'd go 5 times 0 squared minus 0 cubed. So really, I didn't need to do anything. And actually, I didn't need to do anything at all because if I had 0, 0 here, that kind of tells me, right? But I want to make sure that you see the whole process. So yeah, 0, 0. You don't need to write it again. It's just the same thing we already had right there anyways. So that takes care of or checks off the intercept aspect of it. If it's a cubic and we just went over what the shape looks like, are there any asymptotes? There's no asymptote. So it depends on which shape you're working with, and that's why looking at the original function and recalling past information will be helpful to have like a mental picture of what it looks like. I think we're just having one of those days. I believe that every single one of you would have known this is a cubic and would have, on a better day, it's one of those days, right? So for number 3, there would be no asymptotes. And then we have max or min for our next one. So if we are doing max and min, well, our original function from up here is 5x squared minus x cubed. What do we do as the first step to find the max or the min? Yeah, we take the derivative of this thing. So it would be f prime of x. This is too thick. Let's fix that. F prime of x equals, do you see that we would get 10x minus 3x squared? I'm just having troubles fitting it all in, but you all know how to do that. It's just the basic straightforward power rule. Okay, and then we set it equal to 0. So the good thing is that each day we're repeating all of these same steps. So I'm hoping that that repetition is helping drive this point home. We take the derivative, we set it equal to 0, we solve to find the values that allow this to happen. So we, again, are at a point where we need to factor things out here. So we would have 10 minus 3x when we do this. And again, if x is 0, the whole thing's going to be 0. And from here, if x is 10 over 3, the whole thing's going to be 0. And then we'd like to, I feel like I should write x equals and then do that. So it could be either one of these. But if I'm looking for the max and the min, like that's great. I found the x value. I should plug it in and also get my y value that corresponds with this, right? So I am going to do f of, so I take my original, and first I'd plug in 10 over 3. Can I assume that we all know how to do this? Yeah, so I'm just going to tell you. We get 500 over 27. That's maybe not the best way to give it, but that's fine. We're going to leave it as that. And for the other one, when we plug in f of 0, well, the whole thing had x's in it, so do you see that it's just going to be 0? So our max and our min are happening at the point, I should coordinate them, 10 over 3 and this 500 over 27, up to you if you want to reduce that or change it to, whoops, what am I doing? I need brackets, not a box. There we go, and this 0.00, and now I'll put it in a box because that is our max and our min. Okay, we need to find, I'm going to carry on up here and say we need to find our point of inflection. Again, to build and review, so inflection. What do we need to do in order to find the point of inflection? What's the first step? Second derivative. So I take this and I want to go second derivative on this. And so I end up getting that this is just equal to 10 from here minus 6x. I would set it equal to 0. And by isolating, we know x is equal to 5 over 3 when I isolate and reduce that fraction. So we know what the point of inflection is. And if I want the specific value, then I want to take that and plug it into the original, f of 5 over 3, into the original with no derivatives, no nothing. And again, I know that you all know how to do that, so I'm just going to tell you it's 250 over 27. So my point of inflection is 5 over 3 and 250 over 27. Do whatever you like. If you want to change that to a decimal, that might make a bit more sense. If you want to leave it as is, that's fine. But we just want to be able to get that point and get a sense of what is going on here. And then to put this all together, and the reason that we were doing all of this in the first place is that we wanted to get an idea of what this would look like. So we take all of the things that we worked with and we start plotting them on here. So I know that there's an intercept at 0, 0, and 5, 0. So I'm going to put that there, and I'm just going to make a 5 there and put that there. So that's a good starting point. I've dealt with that. There's no asymptotes. I know that there's a point of inflection. Well, maybe I can do this. We have our point of inflection at this point, 5 over 3 and 250 over 27. Probably best that we do convert that into a decimal so that we can see that it would be it's going to go like this, and we're going to have a point that goes like this. So in order to check to see what is going on either side, we would test values as we have been, right? So 0, 0 at this point would be our min, and 10 over 3 and 5, or what was it? 10 over 3 and 500 over 27 would be our maximum point up there. Whoops, I should have just written max. So do you see what I mean by it's the same stuff, but we're now putting it all together again? So it's kind of similar to what we did yesterday, but you get to see the actual application of it. Questions? Okay, we are going to leave it at that. Page 240, numbers 2 to 7 and 9. The only thing, let me remind you, that could change with what we just did is that instead of the cubic polynomial that we started with, You might get a rational function. You might get a radical function. So it could be any of those functions that we've worked with, but you still go through the same step.